Given this equation and a Ka value, write the equilibrium expression for the reaction, just products over reactants to the power of the number in front. That is supposed to be a total layup. Calculate the pH. What we're going to need is the H plus molarity. So we got to find this first. So if we set up an ice box, we know that it starts off with this molarity of propanoic acid. It starts off with no products. One of these is destroyed for every one of these made, every one of those made. So this is our equilibrium amounts. When we do the K math, we get this set up, and we're trying to solve for X because X, it will give us the H plus molarity. However, this is going to be in our way. It's going to make the quadratic formula happen, plus this Ka is too small for it to matter, for this minus X to matter. So I'm going to cross that out. It's going to really speed things up for me. Solve for X. X actually is the H plus molarity. I don't need to add or subtract anything to X or from X. So that is the H plus molarity. And so negative log of that answer will give me pH. On C, we have sodium propanoate. We know all the sodiums will come off, so we've pre-dosed it with a certain amount of propanoate ion, the propanoate minus ion. Now, I don't know how many moles until I convert this to moles, and what I really need for an icebox is molarity. So I'm going to take that in here, and part I actually, it kind of stands to reason that I'm going to have to get molarity of that. In fact, I'm a little surprised they gave us credit for this at all, and I'm not entirely sure in the new test that they would. They might expect us to just know to do that and not prompt us, because we're going to need a molarity of this to get the concentration of H plus. If they just ask me this, I know that I'm dealing with this because I've got propanoic acid. I know it makes this. I know that they pre-dosed it with propanoate ion, and I know that I need a molarity of that to get started. It's not zero, it's some molarity, and molarity is moles per liter. So if I do this math, I get moles. That answer lives in the numerator above liters, divide by liters, and I get molarity. So this is my starting molarity for propanoate ion. Then one of these makes one of these and one of those. And here's my equilibrium amounts, which I'm going to use down here. And again, Ke, which was stated at the top of the page, is too small to matter compared to these molarities. So let's do that. And we can solve for X really easily. And X is this amount, which is the H plus, which is what I was asked for. Here we go. So the only trick really to D is that there wasn't nearly as much of a trick as I thought. What they're saying, and I wish they said it slightly more clearly, is that you have reached equilibrium. Read this as, given that at equilibrium, OH minus is this in this molar solution. So everything has settled out, and you know the molarity of the sodium methanoate. Of course, sodium methanoate means that in water means the sodium comes off, and so that's just the molarity of the methanoate. So this is 0.309 molarity. There is no molarity of water in water, so let's just mentally sort of cross that one out. And I'm telling you, we need to be able to do these simpler ice boxes and stuff in our heads. It's going to be this times that over that, all to the power of 1. And you do have a calculator, so then we just punch that in, and that is KB. And make sure that you know it's KB. How do we know it's KB? Because this is accepting an H plus off of water. There's the acidic H that we put back on. So we took this, it acted as a base, and it formed the acid. So this is the conjugate acid of this base. And you know it acted as a base also because it generated OH minus in the solution. So when they ask for Ka here, how do we get Ka? Well, we're going to divide Kw by Kb, which is one of those things they just expect you to know. I think they might actually furnish this equation written slightly differently in the formulas page, but you got to know that just for time and knowing what Kw is. I think we should know that, and divide, and you get that. Which acid is stronger? Well, since they both generate only one acidic H plus into water each, we don't have to account for anything like, oh, but this one generates one and then some more on a second one. Then we can just go by Ka, and this Ka is in the E-4 range, and this one is in the E-5. and bigger is less negative, and this is less negative, so methanoic acid is stronger.